First, lesion cluster to .matlab file with this foot image, and then you make the color space transformation to type of lab type, and then it begins the cluster this foot image to identify the lesions in the plantar, and then the discriminating this plantar against the background, and then the pressure and the non-pressure area. So this step shows one of the clustering result, and then the blue bounding box has shown as the distinctly as the box and the region are clustered. And then the bounding box are extracted, and then the further development in the code in a MATLAB will be developed. Plantar of diabetic patients are shown here with the area of a lesion, and then the pressure region and the non-pressure region, and then boundary with respect to the background. So first you read the plantar 3.jpg file, and then make them double for the feature extraction, and then 3 different bounding box area of non-pressurized region. The yellow regions are extracted here, and the 9-dimensional feature are extracted. For example, when we look at this feature extraction, it's stepping into the subroutine function, which extracts from the input RGB file, and then the image of RGB file, and the bounding box. For example, the bounding box is the yellow region in the box. And then it computed the projection by looking the image element of Y, X, the 1, 2, 3 is RGB. And then it continues to compute for the various region, and then now it compute for the pressurized region, like the dark color. So for example, when you look at the gradient region, let's look at it. And then let's step it into the subroutine, and inside the subroutine you can step by step examine all of this intermediate variable, the x and the value given from the bounding box, and the y and the value, and then we continue to compute. So all of these 9-dimensional features are extracted. And then the boundary between the foot and the background are computed. The feature extraction takes a little bit time, in total amount around, well, and then it compute for the non-photo image. For example, here we put the hand. So we obtained the 12 different sample area of a 9-dimensional one, and then we computed the covariance matrix and then obtained the large eigenvalue. So from the 12 sample data of a 9-dimensional feature vector, we compute the covariance matrix. So first, this is the 12 sample of a 9-dimensional feature vector, and then what we are going to do is put to them train and the vector beam of this training data, and then we computed the mean and the standard deviation, and then we compute the z variable. The z variable is normalized by the standard deviation for the training data subtracted by the mean value, and then we compute the eigenvector and an eigenvalue and write down the eigenvalue. So let's go through. So for example, in the MATLAB, we can look at the standard deviation and then the mean value, and then we computed the z variable, which is a normalized value, and then we type out the eigenvector and an eigenvalue. So by projecting out to the principal component, which is a large eigenvalue, we obtained the main feature, and then we classify with this main feature.